If you're doing physics paper 2 on Monday, you don't want to risk losing marks because you don't understand lenses. This is everything you'll need to know. Two types of lenses, convex lenses and concave lenses. Convex ones bulge outwards, concave ones bulge in, just like a cave. All a lens actually is a material that bends light. Remember, the bending of light is called refraction, and these are the two types. For both of these, we need to be able to draw ray diagrams. The arrows represent the curvature of the lens, so this one would bulge out, this one would bulge in. This line I've drawn is called our principal axis. It goes straight through the optical center, which is the center of our lens. These Fs represent the principal focus, and this would be the focal length. You'll then have this blue arrow. It will be somewhere over here behind your lens. That represents your object. Now, depending on where the object is in relation to the focal length, that determines the kind of image we're going to produce. But for this example, I'm going to keep these objects at the exact same distance from our lenses so you can compare the two really clearly. To draw any ray diagram, doesn't matter which type of lens we have, we always start with a diagonal line from the top of the object through the middle of the lens and continuing like this. Like so. We then draw a perfectly horizontal line from the top of the object to the lens, the same for both of them. This is where the diagrams are a little different. So for a convex lens, it causes the rays of light to converge, which means go inwards. However, for a concave lens, it causes the light to diverge, which means separate. So on our convex lens, the ray needs to bend inwards. So we continue this ray through this focal point until it meets our other light ray we've drawn here. And notice I've used a complete line here because these are real rays. For a concave lens, however, we need to make the light diverge and bend away. We make it head in the direction so that the light ray heads away from this focal point on this side. Now, it's important for this side of the lens, we use a dotted line to represent a virtual ray. This is because the light ray itself doesn't actually reflect and come back here, it bends and goes that way. But we use this virtual ray here to show it's going in that direction in relation to this focal point. And for any ray diagram where these rays join, that is where your image is produced, represented here by my red arrows. Always vertically from the principal axes to wherever those rays meet. And simple as that, those same steps, that's how you draw any ray diagram. Now, exam questions normally ask you to describe the image that's produced. We consider three things for that. First, consider, is your image magnified or is it diminished? Has it gotten bigger or smaller when compared to your original object? Second, is it upright or is it inverted? And third, is the image real or is it virtual? We say it's real if it's produced by two real rays, which are complete lines when they join. We say it's virtual if it's produced by a virtual ray, a dotted line, when that joins. Now, the description for a convex lens, it depends exactly how many focal lengths away from the lens your object is to start with. But much easier, for a concave lens, you'll always have a smaller, upright, virtual image produced, just like this. And last tiny thing, you may be asked to calculate the magnification. Simply put, that is just your image height divided